Good afternoon, all. So, we are going to start the session. This is the week 3 session. So, let's wait for 2 3 minutes, then we will start the session. Hello, am I audible?
Yes, ma'am.
Yes,
Okay,
ma'am, you are audible.
let's start the session. So, this is a week 3 problem solving session on microelectronics device to circuit. I'm Arpita Biswas, a PhD scholar from IT Jodhpur in Electrical Engineering Department. So, this is more details about me. So here we are going to solve some of the MCQ type question and some of the numericals. Okay, so let's try to solve the question. So this is the question number one. Figure below show the BTC and BJT inverters. Identify the operating region of the BJT in section A, B, C. So first option is section A is cut off. Option B is forward active, then saturations. And there is some other three option also. So go through the picture carefully and then try to solve the question. And there is no hurry, you take your time, but at least try.
Good afternoon.
Yes, good afternoon. What is the right option? Please go through the question carefully and
Option
try
A,
to solve.
ma'am.
Okay. Anyone? Um, Rishika, what is the right option?
Ma'am, option A.
Asta. Can anyone little bit explain why option A? Little bit. Manoj?
Yes, ma'am.
Yes. Little-
When we're
Try to
giving the
little bit explain.
input
Mm-hmm.
voltage less than VB, VB is value is 0.71.
Mm-hmm.
Less than that, the region, the transistor is in cutoff region.
Okay. So option
So
A is
Uh,
cutoff. Okay. And what
yes,
about
ma'am.
B region?
B region, after the cutoff region, it will have it will be in forward active mode, ma'am. There
Hmm.
is a linear decrease here there, and then
Okay.
again after limits, in the C region it becomes saturated mode. There is no increase or decrease in the voltage.
Yes. Yes. This is the correct explanation. So option A is the right option. So next move to the question. And please come before coming to this problem solving session, please go through the lectures. I think there are 5 lectures here, sir already shared in the class. So please go through the lectures so you can. Mainly in my class, I'm going to take some of the MCQs like to clear about your theoretical, and also here we are going to solve some of the numericals. So at first go through the theoretical lecture, whatever sir shared, and then come to the class. Okay. So this is the question number 2. For the inverter in Q1, determine the NMH and NML, assuming the VOH equal to 5 volt and VOL equal to zero point 0.1 volt, and VIH is equal to 2.4 volt and VIL equal to zero point 0.8 volts. So this is the, I think all of you know about it. How to, at first tell me how to calculate this NMH and NML. There is the equation, right? What is the equation? How to calculate this noise margin high and noise margin low?
Ma'am,
Yeah.
MMH is equal to VOH minus VIH.
VOH minus VIH. Okay. And NML noise margin low
V-
equal to?
VIL minus VOL.
Yes. So tell me the right option.
Solving,
Just
ma'am.
calculate. Yes. Just calculate the, and how we have to how we get this NMH uh, noise margin high equal to this VOH and VIH. You have to go through the lectures. Now the lecture I have taken directly that NMH equal to VOH.
Option A, ma'am.
Okay. Yes, option A is the right option. VOH minus VIH. So what is the value of this 5 minus 2.4?
2.6.
Yes, this is 2.6. And I think last I have taken 4 to 5 numerical question, and on others total I have taken 30 question, and fives are numericals and others are just MCQ types to check your theoretical concept. Okay. And what about this NML, the noise margin low? Tell me the equations.
VIL minus
VIL,
VOL.
yes, VIL. And what is this VIL and VOL? Please go through the lecture at first. And this is equal to zero point 0.8 minus zero point 0.1. So the ultimate value is zero point 0.7. Is my slide is visible? All of you? Whatever I'm writing
Yes,
here?
Yes,
ma'am.
visible.
Okay. 0.7 volt. So the right option is option A. Okay. So next move towards the question number 3. Considering base width modulation in a BJT, the decrease in base width cause beta to dash, hence the collector current IC dash with the collector voltage. So first option is increase, and option B is the increase decrease. Option C is the decrease increase, and option D is the decrease decrease. So go through the
Okay.
question carefully. Considering base width modulation in a BJT, the decreases base width cos beta to dash. Hence the collector current IC dash. At first, tell me what is the
Increase,
relation between
decrease.
this beta and yes, so what is the right option?
Increase, decrease.
Increase, decrease. Uh, Anyone else? What is the right option? At first, tell me what is the relation between beta and IC. Tell me
Beta
what
is
is
equal
the
to
relation?
IC by IB.
Yes, IC by IB. So tell me, if beta is increasing, then what about this IC? It is increasing or decreasing?
Increases.
Beta is increasing, so
Increasing.
IC is increasing or increasing. It is directly proportional, right? See carefully. If beta is increasing, IC is also increasing because it is directly proportional. But what about this IB? It is inversely proportional. So if beta is decreasing, then IC is also decreasing, and beta is increasing when IC is also increasing. Okay. Now tell me what is the right option in considering base width modulation in BJT. The decrease in base width cause beta dash. If decrease in base width, then beta, what about this beta? It will increase or decrease?
Increases.
Yes, yes, it is increases. So if beta increases, then what about this IC? It is increases or
Also
decreases?
increases.
It is also increases. Yes. So the right option is option A. Is it clear to all of you?
Yes, ma'am.
Yes, ma'am.
Okay. So this is the question number 3. In the base width in a bipolar junction transistor is doubled, which one of the following statements will be true? First is the current gain will increases. Option B is the unity gain frequency will increase. Option C is the emitter junction capacitance will increase. And option D is the early voltage will increase.
Ma'am, option A.
Option A, current gain will increase. Anyone else? Asta, what is the right option? Hari, Ramya.
Option C, ma'am. Third option.
Okay, Ramya, what is the right option? If the base width in a bipolar junction transistor is double, which one of the following statement will be true? Tell me what happened. If the base width is increased, then what will happen? Like the base
Fourth
current is
option, ma'am.
also increased. Yes. Which option?
Early voltage will increase.
Sorry, I'm not getting you. Which option?
Fourth option, ma'am. Early voltage
Yes.
will increase.
Yes. Option B is the right option. Can you little bit explain? Then I will tell. What is the reason
Yes, ma'am.
behind it? Yes.
Early voltage is a measure of output resistance of a transistor,
Hmm.
and it is related to
Listen,
the base with
all of you,
modulation,
please
ma'am.
listen carefully. Or any of you are telling something, please, all of you listen carefully. Yes. Tell me again. What is the reason?
It is the measure of output resistance of a transistor, ma'am.
Hmm.
Actually, it is related to R naught. R naught when VA is tends to infinity means R naught also tends to increase. Similarly, when both are related, ma'am. So it is related to base
Yes.
with modulation also. So when
Okay.
base with double means the base with modulation that effect will be reduced, ma'am. The base early effect will be reduced. So it will
Yes.
increase the early voltage.
Okay. So the final answer is as the base width is increased, the base current will also increase, thus reducing the collector current. Okay. So the collector emitter characteristics will be more flat. Thus the extrapolation of the collector current will be further. So early voltage will also increase. So the right option is option D. So next move to the question number 5. I think all of you know this answer. The approximate temperature dependence of mobility due to lattice scattering is option A is T by half, option B is T by minus half, and option C is T by 3 by 2, and option D is T by minus 3 by 2. So what is the right option? The approximate temperature dependence of mobility due to lattice scattering.
3 power 3 by 2.
Is it 3 by 2 or minus 3 by 2?
3 by 2, ma'am.
You can recheck it. Okay. 3 by 2 or minus 3 by 2. You can recheck this answer. So this is the
Ma'am,
question of,
actually, ma'am,
yes.
ma'am, I think minus 3 by 2, ma'am.
Yes,
I think so.
minus 3 by 2 is the right option. You can recheck it also. Maybe I am also
Okay.
wrong. Okay, you can recheck it. This is the question number 6. In an N-channel enhancement MOSFET, onset of inversion take place at VGS equal to VTH, VGS greater than VTH, or VGS less than VTH, or does not depends on the VTH. So in N-channel enhancement MOSFET, onset of inversion take place. It's meant when the inversion starts, like it is VGS equal to VTH or VGS greater than VTH or VGS less than VTH. The VTH is the threshold voltage. So if it is less than one by one, we can go. If it is less than the VTH, the threshold voltage, it will on or off in channel MOSFET. Like this type of structure there is. N channel means it is P type of substrate. Okay, N plus plus and then N plus plus. Then you are like MOS structure, metal oxide semiconductor. Okay, then tell me, the inversion, like this type of inversion is take place. The inversion is take place when, if threshold voltage is sorry, the VGS voltage is greater than threshold voltage, or it is equal to or less than.
First option, ma'am.
Yes, first option. Because when it is equal to this VTH, then the inversion take place. Okay. And this condition also the MOSFET is on condition like VGS greater than VTH, but it will start on this condition like VGS equal to VTH. Okay, good. So this is the question number 7. The conventional limit for subthreshold slope of MOSFET at 300K is 40 millivolt per decade, 60 millivolt per decade, 80 or 100 millivolt per decade.
60 millivolt per decade.
Yes, 60 millivolt, good. Millivolt per decade. Next is the question number 8. I think all of you will try to solve this question. Consider a MOSFET as shown in figure below. What will be the change in ID if VDD change from 3.3 volt to 1.8 volt? Consider the VTH equal to zero point 0.5 and mu and COX W by L equal to 100 microampere per volt square. So this is the structure. So try to calculate it. And there is no hurry, you take your time. I think this is the one numericals, and then we are going to discuss about 10 to 15 MCQ, and then I have put it 4 to 5 numericals also. So please try to solve it. Go through the question carefully. With VDD change from 3.3 volt to 1.8, and then you have to find out the change, like the change in current, the drain current, ID. If the VDD change 3.3 to 1.8, then how much change in ID? Like this MOSFET works, and when one condition it will work in a saturation mode, in other condition it will work in a linear mode. So there is two different equation how to calculate this ID. Okay. Now tell me what is the right option.
Kindly teach to solve this sum.
Sorry.
Kindly teach this sum.
I have to like solve or you will try.
Yes, ma'am.
Okay, take some time. Anyone is trying? Hari, Rishika, at least try, na. Like,
Ma'am,
okay,
1
I'm
minute,
giving
ma'am.
you the yes, I'm giving you the hint. Okay, just a minute. Now, like how to calculate. See, when the VDD is 3.3, take first condition, case one. Okay, VDD is 3.3. Not totally, I'm going to solve. You guys solve, but I'm going to give some hint. Like case one is VDD is equal to 3.3. Okay. Now tell me if VDD is equal to 3.3, then VDA is equal to what?
1.8.
VDA is there any voltage is there?
No, 0.
Yes. So VDS equal to also this 3.3, right? Just a minute. Yes, the VDS is equal to also 3.3. Now tell me what is the condition for this MOSFET going through the saturation mode? Like, do you know? Hello?
Hello, ma'am. Hello, ma'am.
Yes.
How can we solve this problem like this? ID equals to half million T of W by L VGS minus VGS whole square.
Yes. So first I'm going to take the condition. Like if the VDS is 3.3, then what is the condition? Like VDS is greater than the VGS minus VTH. Like in VGS minus VTH. Now tell me what is the value of VGS minus VTH if this condition is satisfying or not. VDS equal to 3.3. And what is the value of VGS minus VTH? Tell me what is the value of VGS minus VTH? All the values are given here.
2, ma'am.
Yes, 2.5 minus 0.52. So is this condition is satisfying? This VDS greater than is VGS minus VTH? Yes or no?
I think the answer is 2 microampere.
Yes, the answer is 2 microampere. Good. So tell me, is this condition is satisfying or not? The VDS is greater than VGS minus VTH? Yes or no?
Yes, ma'am. Yes, ma'am.
So
Yes, ma'am.
which condition, like if VDS greater than VGS minus VTH, then MOSFET is operating in saturation or linear? Tell me, is it is working on the saturation or linear? If VDS greater than VGS minus VTH, it, it is working on saturation.
Saturation.
Yes, saturation. Now tell me what is the equation for the saturation mode so how to calculate the ID? Tell me in saturation mode, how to calculate this ID? Tell me the equations. What is the equation in saturation mode? Half of,
Half of
yes, mu1 COX
mu n COX W by L VGS minus VTH whole
minus
square.
VTH whole square. Good. So now calculate the ID value. I'm not going to solve all these things. Now calculate the ID value. Half of mu1, all the values are given here. Mu1 COX W by L.
And 200 microampere.
Yes. VGS minus VTH, VTH whole square. Okay. So what is the value here? The ID is 200 microampere. Just put all this value. At first check is it in saturation or the linear. If it is in saturation, then there is the equation that's ID equal to half of V1 COX W by L into VGS minus VTH whole square. Okay, microampere. Now tell me there is another condition that VDD changed from the 3.3 to 1.8. Now take this condition. Now tell me, is this equation is like satisfying this equation like VDS greater than VGS minus VTH
No,
or
ma'am.
it is less than VTH
Less than.
or
Less
something?
than.
Yes.
Less.
Linear.
Is yes. So the MOSFET is operating in linear. So second case, case 2. VDD is 1.8. So VDD is 1.8, and so it is less than or equal to VGS minus VT, so it is in linear mode. Okay. Now tell me what is the equation for ID in linear mode?
U1
MOSFET in
COH W by L VGS minus VTH into VDS minus VDS square by 2.
yes. So ID is equal to mu1 COX W by L into VGS minus VTH.
Ma'am, ID is 198 microampere.
Yes, 198 microampere. VGS minus VTH into VDS. So here, what is the value of VDS? VDS is equal to 1.8 minus half of VDS square. So what is the value? It is 198 microampere. Now tell me what is the difference? So how much change is there in ID?
2
So the
micro.
change in ID is 2 microampere. So the right option is option C. So all of you got the answer? Is there any doubt? Or I can move for the next question.
Next question.
So, yeah, okay. So this is the question number 9. A MOSFET operating in linear region behaves as a dash. Well, in saturation region, it's behave as a dash. First option is the current source. Second is the capacitor. Option B is the resistor current source. Option C is the resistor inductor. And option D is the capacitor current source. So what is the right option? MOSFET operating in linear region.
I'm
And
option B,
also,
ma'am.
Resistor and current source, ma'am.
Resistor current source.
yes, option B is in linear, it's wave like register, and its saturation, it's like current source. So next move to the question number 10. Just a minute. In order to have zero substrate bias effect, the substrate of an p-channel enhancement mode MOSFET should be. First option is connected to the most positive bias. Option B is the connected to the most negative bias. Option C is the grounded or option D is floating.
Option A, ma'am.
Okay. connected to the most positive bias. Good. So this is the question number 11. In a simple BJT inverter, the output is taken from emitter, collector, base or ground.
Collector, ma'am.
Yes,
Collector.
collector. Okay. So question number 12. The VOH is given 5 volt. Um, sorry, I think. Okay, so VOH value is given 5 volt and the VIH is given as 1.66 volt and the VIH is okay, just leave the question. I think it is not clear. This is the question number 13. Why is the switching speed of a BJT inverter slower than the CMOS? First option is due to the storage delay from base charge removal. Option B is the due to the higher capacitance of base. Option C is because the collector resistance is low. And option D is because the emitter is grounded. Any of you? At least try.
Ma'am,
Yes.
ma'am, ma'am, I think
Yes.
option A, ma'am. I think option A.
Yes. Option A is the right option. Good. Due to the storage delay from the base channel removal. Yes. So next question number 14. Which of the following is not a second order effect in BJT discussed in the lecture? First option is the drift in the base region. Second is the Arley effect. Third is the avalanche breakdown. And option D is the thermal runaway.
Drift in base region, ma'am.
Okay. Anyone? Any of you? What is the reason? Please practice all this type of question. Okay. In also exam also this type of question is going to come. That's why I'm going to solve the daily, like in each class, 30 to 35, this type of numericals and the theoretical based MCQ question. That's why first go through the lecture carefully and then come to the problem solving section. It's very important. So the right option is the thermal runaway. Okay. Next question number 15. Early effect in BJT caused by increase in emitter doping, reduction in effective base width due to the reverse bias at base collector junction. Option C is the reduction in collector doping, and option D is the increase in forward bias at base emitter junction.
Second option.
Any of you? Any other? Yes, the right option is the second option, reduction in the effective base width due to the reverse bias at base collector junction. So this is the cause of the early effect. So next is the question number 16. Avalanche breakdown in BJT occurs when base emitter junction is forward biased heavily. Option B is the base collector junction reverse bias exceed the breakdown voltage. Option C is the collector emitter junction is forward biased heavily. Option D is the thermal energy causes the carrier multiplications. At least try. What is the right option?
Ma'am,
Yes.
base collector junction reverse bias extends from breakdown voltage.
Yes. Option B, right?
Yes, ma'am.
So, yes. Base collector junction reverse bias exceed the breakdown voltage. The question number 17. In a BJT, minority carrier contribution to collector current approximately doubles for every 1 degree rise in temperature, 5, 10, or 20.
10 degree, ma'am.
Yes, 10 degree in temperature.
Temperature.
So this is a question number 18. In the low level injection condition, why is the assumption of negligible recombination invalid? First is very large injection current. Second is the small number of injected carrier makes the recombination significant. Option C is the high doping concentration in emitter. And option D is the large depletion width.
Ma'am, is it option B?
Yes, option D. Small number of injected carriers make recombination significant. Next question number 19. What happened to carrier mobility in a BJT as temperature increases? Increases, remain constant, decreases due to the increased lattice scattering, or increase due to the high diffusion coefficient. What happened to the carrier mobility if temperature increases?
Ma'am, decrease due to increased lattice scattering.
Yes, yes. Good. The
Option
option
C.
C is the right option. Yes. So next question number 20. In an NMOS device, the substrate is typically N-type, P-type, intrinsic, or degenerately doped N-type.
P-type.
Yes, it is P-type. Good. The question number 21. What is the relation between the effective channel length and drawn length due to the lateral diffusion? Is it L effective equal to L drawn, or L effective equal to L drawn minus 2LD, or L drawn plus 2LD, or L drawn by 2?
Ma'am, option B, ma'am.
Yes, option B. A little bit you can you explain? Little bit. Why L effective equal to L drawn minus 2LD? Why this
Between
2LD coming?
relation between effective channel length and drawn length due to lateral diffusion.
Yes, lateral diffusion, like for the source and drain, like it is heavily doped, this N plus N plus. So that's why this the LD is coming. So from the source and the drain, both side is the LD is coming. And so the L effective is equal to N drawn minus 2LD. So the question number 22, which MOSFET type is called the normally the off device? Depletion mode, enhancement mode MOSFET, or junction FET, or CMOS? Which MOSFET is called
Option B.
normally off? Yes, option B. Enhancement mode MOSFET. So next question number 23. In an enhancement mode, NMOS applying VGS greater than 0. So first option is repels the electron from the interface. Option B increases the hole density near the interface. And option C is attract the electrons towards the silicon oxide interface. And option D is creates a depletion region in the source.
Ma'am, option B, ma'am. Increases hole density near the interface.
Yes, question no. Question number 23. The go through the question carefully. Like the attracts the electron towards the silicon oxide interface. Okay, the right option is option C. This is the question number 24. Inversion charge density in a MOSFET above the threshold is proportional to VGS, VTH, or VGS minus VTH, or VDS. So what is the right option? It is option C, the VGS minus VTH. Next question number 25. The conventional thermal limit for the subthreshold slope at 300 K is 30, 40, or 60, or 90. I think already we gone through this question. The
60.
conventional thermal limit, yes, 60
C.
millivolt, yes, 60 millivolt per decade. The question number 26. In the linear region of MOSFET operation, ID is approximately independent of the VDS, directly proportional to the VDS, quadratic with the VDS, or zero.
Directly proportional to VDS.
Yes, directly proportional to the VDS. Option B is the right option. Good. The question number 20. So here I have taken, I think, 3 to 4 numericals. So here given this mu value, COX, WL, and VTH and VGS. So calculate the saturation current. So directly put the all these things in the equation and tell me what is the value of the ID in the saturation mode. Just calculate it.
Ten to the power minus three.
Sorry. Uh, what is the value of ID? No, it is not 10 to the power minus 3. Is there is something before this 10 to the power, or only this 10 to the power minus 3 ampere?
Only 10 to the power minus 3 ampere I'm
No,
getting.
no. Just calculate carefully. I have given all the value. The mu value is given. COX value is also given. W by A, WL is given. VTH, VGS, all
Ma'am,
these things
2
are
into
given.
10 to the power 3. 2 into 10 to
Yes,
the
2
power
into 10 to
3.
the power minus, I think minus 3, right?
Yes, ma'am.
Yes, 2 into 10 to the power minus 3, or 2 milliamps. Just carefully calculate. All of you are getting or not? Just 2 into 10 to the power minus 3 ampere.
My answer is 2 milliamps.
Yes, 2 milliamps.
Can you
Okay.
explain it once? 2 millions.
Sorry.
Can you explain it once?
Yes, I'm going to solve it. See, what is the value? At first, tell me what is the value of this VGS minus VTH? VGS minus
2.
VTH. Yes, it is 2 volt. VGS minus VTH equal to 2 volt. So, what is the value of W by L? W by L equal to also 5, right? W by L
Yes,
is 5,
ma'am.
right? Yes. So, is it? Now tell me what is the value of the mu n COX? Mu n COX. The value of the mu n COX, so the like it is the centimeter square per volt second. So 500 into what is the value of COX? It is 4 into 10 to the power minus 7. So what is the value of it? This is the 2000 into 10 to the power minus 7. 2000 into 10 to the power minus 7. Just check the calculation carefully. Maybe I'm wrong, but check the equation carefully. So 2 into 10 to the power minus 4 ampere per volt square. Ampere per volt square. Now tell me, just put this all these things in the equation. What is the value of ID? ID equal to half of mu. But just take the equations. Half of what is the value of mu and COX? Mu and COX is 2 into 10 to the power minus 4. 2 into 10 to the power minus 4 into W by L. W by L is equal to 5 into VGS minus VTH. What is the value of VGS minus VTH? It is 2. So 2
2.
square is equal to 4. Just cross this. So 20 into 10 to the power minus 4. 20 into 10 to the power minus 4. This is an ampere, right? So tell me what is the value of it? 2 milliamps. Can you tell this is 2 milliamps? Is it clear for all of you?
Yes, ma'am.
All the children? Yes.
Yes,
So
ma'am.
can we move toward the next question, the question number 28. So here is also same way. The mu1 is given, CUX is given, WL, all these things are given, VTH, VGS, and VDS. So you have to calculate the drain current, which is in linear region. Also the equation is given. So the same way you have to find out the ID when the MOSFET is in linear region. So tell me what is the value of it?
Ma'am, 217.35 into 10 to the power minus 6.
Is this the right option? Anyone else? Have you calculated? I think the answer is 4.968 into 10 to the power minus 4. Just see the calculation carefully. The VDS is value is given. Just find out. At first, tell me what is the value of the mu and COX. 450 into 3.43 into 10 to the power minus 7. So what is the value of mu and COX? Tell me. Mu and COX is equal to 1.5525 into 10 to the power minus 4 ampere per volt square. Then what is the value of VGS minus VTH? It is
Ma'am,
1.7. Yes.
whether the answer is 21.735.
No. Just see it carefully. Mm.
0.49 milliamps.
Yes, 0.49 milliamps is the right option. Just first calculate tell me what is the value of W by L. It's simple. You just have to put all this
10.
value in the equation. It is 10, right?
Yes,
W by L is 10. And tell me what is the value of the mu and COX. Mu and COX. Just ignore my handwriting. Mu and COX is equal to 450.
into
Same, yes. 450 into
3.45
3.45 into 10 to the power. Tell me what is the value, the final value?
1.55 into 10 power 10.
Yes, 45 into 10 to the power minus 7. 10 to the power minus 7. The value is 1.55.
Into 10 power minus 10.
Yes, 1.55 into 10 to the power minus 4. Minus 4 ampere per volt square. So what is the value of VGS minus VTH is 1.7, right? VGS minus VTH,
1.7, ma'am.
yes, 1.7. Just put all these things in the equations, the ID. Now tell me what is the value of this ID. This ID equal to like mu and COX. This mu and COX equal to 1.55 into 10 to the power minus 4. Into W by L is equal to 10, right? And then VGS minus VTH. VGS minus VTH is equal to 1.7 into VDS. What is the value of VDS? 0.2, right?
0.34.
VDS is, yes, 0.2 minus
0.0.
VDS square by 2. So 0.2 whole square, 0.2 is total whole square by 2.
4.96, ma'am. 4.96 in 10 power minus 4.
Yes. So the answer is 4.96
96
into 10 to the power
minus 4.
minus 4. Yes, this is the right option. So next, move toward the question number 29. So here also for an NMOS, ID is given, mu and COX is given, W by L is also given, VGS is also given. So you have to find out the VTH. So and the MOSFET is operating in the saturation. I'm not going to solve you. All of you have to solve this. Just solve the value of VTH. The equation is given. The NMOS is operating in the saturation, And the ID value given, mu and Cux is also given, W by L is given, and VGS is given. Tell me what is the value of VTH? The same way you have to calculate.
வாங்க பூஜா.
Whether VTH is equal to 1.56.
4 volt. Yes. The right option is 1.564 volts. All of you, please calculate and tell me, are you getting the same answer, the VTH value? Then I think there is one more question. Question number 30. Okay, let's solve this question. So mu and Cux, half of mu and Cux W by L is equal to, what is the value of it? Tell me. Mu and Cux is equal to 200. Hello, am I audible? 200 into 10 to the
Yes,
power
ma'am.
Ma'am, yes, ma'am.
minus 6. 10 to the power minus 6.
Ma'am,
5 to,
answer is 3.5.
no, 3.5 is the value, 3 point, no. 3.5 minus, you have to minus the value of VGS, I think. So 3.5 minus 1.93. So the value of VTH is equal to 1.56. See, this is the value of the mu and Cux by 2 into W by L. W by L is equal to 4. So what is the value of VGS minus VTH? Uh, yes, they are into the VGS minus VTH. Later we are going to calculate VGS minus VTH whole square. So what is the value of this ID? ID is given 1.5 into 10 to the power minus 3. Okay, this is a milli. 10 to the power minus 3. So what is the value? This right side is the 400 into 10 to the power minus 6 into VGS minus VTH whole square. Now tell me what is the value of the VGS minus VTH? VGS minus VTH whole square is equal to 1.5 into 10 to the power minus 3, 1.5 into 10 to the power minus,
3.75.
yes, yes, into 400 into 10 to the power minus 6. So VGS minus VTH equal to 3.75. Okay. So now tell me what is the value of the VTH? Uh, yes, the 3.75 is the value of the VGS minus VTH whole square. So the value of VTH, VGS minus VTH, VGS
1.9.
minus, yes, minus VTH is equal to 1.935, 1.935. Okay. Now tell me what is the value of VTH. Just from here, calculate. VTH equal to, because VGS, I think it is given 3.5. So 3.5 minus is 1.935. So what is the final value of the
1.565.
VTH? Yes, 1.564 or 1.56. Yes, 1.56 volt. This is the right option. This is the question number 30. WL value is given, COX is given, and VTH is given. So in the linear region at VGS equal to 2.5 volt, VDS equal to 0.1 volt. So measure the drain current ID 1.2 milliamps, find the mu n. So these things are given, you have to find out the value of mu n. So and it is in operating in which region? The linear region. So please find out the value of mu n. Like in linear reason, whatever the equation of ID, just write it. The value of ID is given, and all the VGS, VDS, and all these things are given. So you have to find out the value of mu. Just tell me what is the value of the mu. Tell me what is the value of the mu. Just put all write the ID is equal to mu and COX W by L into VGS minus VTH into
1 minute,
VDS.
ma'am.
Okay. Okay, calculate. Because I'm not going to calculate this numericals. All of you have to find out it. The same way you have to find out it. Just write this linear equation ID, put all the value and find out the value of mu. And next station I will take on the next Tuesday, 7 to 9 p.m. But before coming to the, it is my request that before coming to this class, please go through the lecture. This is the next, I think this is the week 4. This is the week 3 and next is the week 4. So there are some 4 to 5 lectures are there, are already, I think, shared. So please go through the lecture carefully and then come to this session. So it will be easier for you also to understand from where which equation I'm using, from where I'm taking this numericals and the theoretical question also. So it will be easier for you. So what is the value of mu here?
24 into 10 to the power 10 to the power 4.
It is 2068. Okay, centimeter square per volt second. Just see it carefully. The value is 2068 centimeter square per volt second. Because W by L is 10, VGS minus VTH into VDS minus VDS square by 2. Just calculate this value. This is also 0.145. So one side write the value of ID, it is 1.8 into 10 to the power minus 3. And in the right side, the mu n into 4 into 10 to the power minus 7 into 10 into what is the value of this total? 0.145. So then what is the value of mu? The mu is equal to 1.2 into 10 to the power minus 3 by 5.8 into 10 to the power minus 7. So the ultimate value is 2068 centimeter square per volt second. Is anyone getting this answer? The mu value is 2068.
Yes, ma'am. 2068.9.
Yes. Okay. So we are ending the session here. Or I have to calculate it. Tell me. You will find out the value of mu. The mu value is 2068. Okay, whoever is done, you can leave. Next we'll meet in the next Tuesday, 7 p.m.
Thank you, ma'am.
Okay. Or anyone having any doubt, then I will write it. I will calculate it. Or you will find out the answer. Whoever is done, you can leave the meeting. So I have to calculate or you will find out. The value of mu is 2068 centimeter square per volt second.
Excuse me.
Hello?
Ma'am, excuse me, ma'am.
Sorry, I'm not getting you. What?
Ma'am, I got answer to 28.97 centimeter square.
The right answer is 2068. Matlab 2068. Okay?
Yes, ma'am. I got it.
Okay.
2068.95 centimeter square.
Yes, this is the right option. Yeah, right answer. You can leave. Okay. And for others, can we end the session here? Hello? Can discuss the topic. Okay, so we are ending the session here.